So thank you for Mr. Benvegnu's sharing. May I now pass the mic to our moderator of today's panel discussion, Mr. Ben Cheng, Vice Chairman of Internet Society Hong Kong. Ben, please.
Hi, everyone. So we are going to have a panel of web development best practice today. And let me invite the panelists to join me here on stage. First, I would like to invite Christians of Elastic, Matt of Mondo, Davide of founder and CTO of DBTek, and Linus of Chaos Computer Group. Okay, cool, so let's keep it up. Okay, well, we'll have like maybe 20 minutes of discussion, and then we will give the Q&A session. We'll take some questions from the floor. By the way, yeah, Ben, Vice Chairman of ISOC from our sky. So, so maybe let's just start by like just sharing a little bit, like what you personally think about like what's your best practice on like what do you think is the best tips to developers on web development? And while we are at it, like can each of us pick like one of your favorite framework on web front end or back end development? Shall we start? Like anyone who takes it?
Well, in my opinion, there are three things that we need to care about when we develop and design a web application. The first thing is to not over-engineering, not do over-engineering, because I've seen a lot of times very complex architectures for a web application that serves just 100 users. And I enjoy to design up architectures, also very complex architecture, but when you do that, you should keep in mind that maybe someone else should have to touch your application, and then also when it's over-engineered, sometimes the performances are not so good. So my first advice is not try to over-engineering your application. Just I cannot say that simple is better, but maybe halfway is the way to go. To scale, you will face some serious problems. And the third one, I'm maybe on that side, but consider to adopt DevOps or at least continuous integration mechanism, because in that way you can avoid a set of problems that you can have if you don't do it. You can check your code, you can check your code quality, you can test it in an automated way, and it's really important to at least for me, to achieve your application quality that you want to.
So to, I guess, back up what David said there, I sort of agree with all those statements. Mine, especially with my background, is scalability. I think as businesses grow, being able to architect your system with scalability in mind will keep that growth going without you hitting sort of major hurdles along the way. As well as that is not trying to save the world all at once. And with world, I guess it's your application. Try not to build everything that you think your application needs to do straight away. Have a target audience or a target market and build incrementally on that. I guess it feeds back into that DevOps practice there of just building really good, tight features that's going to get your product into market and go from there.
Two in one. Okay, so my view on web applications is a bit different because I only see them professionally in as part of security tests. So I don't care too much about the application or what it does for users. I care about how I can break it. And unfortunately, there are some mistakes that are just repeated again and again, and that are not very hard to avoid. Nonetheless, one of my colleagues, Mario Heiderich, always calls web application security the Paralympics of IT security, because they're on a very low level of, and a very easy low-hanging fruits that you can find. So what I observe in many web applications is that they are over-engineered in terms of complexity, and that they try to solve this very simple problems in ideally most complicated ways. And that is why I believe it is most crucial to think about what exactly your application is supposed to do, and do that one thing right. And then you can think about integrating it with others. So I very much like the idea of having a team that is capable of creating a mere 500 applications in a very short time, because they're all very small single-purpose applications that you can then integrate later. So what are the mistakes that we always see in web applications? Number one is input validation. Again and again. I don't know why you still find it, right? So the most beautiful finding I've ever seen in my professional life was a buffer overflow in the password prompt. So you could take over a whole platform just by the password prompt. So you would get better privileges than anybody could achieve on that machine, or should achieve on that machine just by entering a long password. So you need to identify your trusted sources in which you then sanitize and evaluate the user input that you receive. Another beauty is a authentication check in JavaScript. So the client-side JavaScript would return to the server, yes, the password was right. So that, of course, is very simple for a hacker to fake, and then you suddenly have access to everything, because people outsource crucial application logic to the client side, which you shouldn't do. In general, authentication and session management is a big problem. You should rely on a central authentication entity. And once you do authentication, and once you give users an identity and some privileges, of course, you also need to rely on encrypted communications. The best authentication framework doesn't help you if you're then transmitting the cookies in plain text, so for anybody to steal on a public Wi-Fi. And the third best practice that I notice is with regards to error handling and logging. So oftentimes web applications would give security relevant debugging information on the front end side to any user. So if I find a glitch in the application, the application would give me a stack trace or something to explain what went wrong, to help me debug the feature. Of course, when I debug something, I have a different goal. I don't have the goal to remove the error, I have the goal to exploit the error, so I shouldn't be given that information. And on the other hand, I see once we tell clients to not do, to not collect or to not output error and debugging information, we see that they also don't store it for themselves, which is the next mistake, because you want to see what your application does, and you want to see the glitches and errors that people provoke in the application, so that you can ideally live debug. And that's where I think it becomes an art of logging in a first step all kinds of debug information that your application produces, and then in a second step identifying what is relevant and having the correct monitoring algorithms to make meaningful information out of what you're logging. So I think those are the three principles that I see most often violated.
Yeah, so I think these guys have largely covered the main important parts. One advantage to going last, I guess. For me, the important thing we have where I work is that things need to be as simple and as quick to kind of implement as possible. And the advantage of like using frameworks for web development is that you're not reinventing the wheel, hopefully introducing bugs that people have repeatedly fixed again and again. So a good one on security would be XSS outputting like script tags back out into your page. Like all common frameworks in theory have like fixed those. And the React framework in particular, there is a method that allows you to disable it, and it's about this long and is output extremely unsafe HTML onto this page. And you have to type that out in your code in order to like put that on the page. So I think for us that it's using the right tool for the job. And there are some extremely complex frameworks such as React and using Flux, which I find for most jobs is probably a bit too much. But then the other end, there's really nice templating frameworks like Jekyll, which we actually use for our kind of main website, which allows non-developers to really quickly update things. We can review those through pull requests, and then we can quickly deploy those immediately onto the internet. So for us, it's really ensuring that people have an extremely simple workflow for web development, but that we provide the tools to make sure they can't make mistakes and like continually have our systems exploited.
So I saw a very interesting thing mentioned here, keep repeatedly, is like try to keep it simple and at the same time make it scalable. I think I saw a lot of like development team out there like who build things like over engineering stuff, build things too complicated, is because that they thought it would help them make it scalable. So what do you think is like the right balance, or what is the common things you see people like over engineer but which doesn't help? Or how do you think the development team, or even sometimes I guess the business manager generally, like how should they see the issue of scalability versus complexity?
From my experience, it's always been reinventing the wheel. Like you'll have a small team that's building a web application and they want to put in a persistent queue, for instance, for part of their architecture. And instead of using something that's on the market, that's open source, it's been tested, it's been hardened, they decide to build their own and go ahead and think, well, we can do this better, we can make it more scalable, make it more tuned to our own system. And then they find 6 to 12 months down the track, they have no product yet, and then they're still trying to invent a persistent queue. So it's reinventing the wheel in that regards, that you try to avoid that, and by making it simple, it's using tools that are already out there and that are production ready, in a sense that they are being used and tested by others.
Also about scalability, there is often a common mistake that people do, because especially right now that you can leverage on cloud technologies, they just think, okay, I put my application on 3 different nodes and it will scale. Sometimes it's true, just keep adding some nodes to the clusters or to your balancing set will work, but most of the time it won't. Because if your application is not designed correctly to scale, it will not scale in an effective way. One very simple example is when your application uses hugely the session. And if you don't design a kind of session manager to be able to scale, and you don't take care of what you save in the session, you can use maybe 10,000 nodes on your cluster, but your application won't scale. Or worst, will not work on more than one server, is even worse. So don't think that scalability is only about the platform and the server and the servers, but you can and you should design your application to be able to scale.
So I think there's 2 things there. On the one hand, scalability is a really good problem to have. Like fundamentally, if you are launching a new product and you don't get to the point that you have scaling problems, you probably don't have any customers. So like scalability is a great problem to have, but arguably it's a problem that doesn't happen on day 1. It happens in 6 months or 12 months. And that means actually, although in some cases, you should be aware of the compromises that you're making. So there may be things that you know are not necessarily scalable, but you could fix them if you spent a week or 2 like working on them. And those things are things that you can defer to the future. You can leave those things and do them later. On the flip side, there are problems that if you don't think about them up front, they may take 6 or 12 months to fix. And then at that point, when you do hit those scaling problems, you can't change them quickly enough. And at that point, then your business has serious problems. So I think you just have to be very aware of what those problems are and make a conscious decision on whether to put the work in now or put the work in later. The other thing is there are a huge number of tools that we can use and reuse that are well tested and that do everything from extremely scalable databases to really persistent message queues. The problem that I see is that people use everything. And while that's great, and it does mean that they're using tools that are well tested, it means that you now have an operations team or all of the developers who are kind of using their software now have to monitor the logs of 10 or 15 different systems, and they have to be experts in how to run these systems in production. So there are quite often cases where you could use a tool that you already have in your stack, and it's not perfect, but it does like 80% of what you need it to do. And that would probably be a better choice than introducing another tool, another component into your stack, which you then have to monitor, test for scalability, and make sure it's secure.
Okay, so another thing I think very interesting we just talked about is about security. So like there's like all kind of security problems that we think is very amateur, but then we keep seeing it on production system. And then like, so say if like I'm like, if like someone there or I'm like the development lead of like 5 to 10 people team, besides like ask everyone to like, hey, go like try harder. Is there any like practical tips you think that would be useful for a team at that size to be more security aware and do better on web or internet security in general?
Probably the best or one of the most important approaches is to think about ways that the system could be abused or the application could be abused. Oftentimes, besides the obvious vulnerabilities that you find, okay, somebody takes over a user's account or something, there are different vulnerabilities that maybe do not even harm the application owner in their sense, but harm somebody else and and serve an attacker's motivation well. So I oftentimes see that people very much care about how can somebody break the application, or how can somebody, harm us as the application owner. Sometimes people think about how can somebody harm our users, but rarely people think about what could be an attacker's motivation with regards to this system. And they can be very, very simple and very different from what you think. For example, I've seen applications that would provide users with storage. So user gets storage. At the time, storage was a scarce commodity on the internet, and attackers were happy to have storage. So people would just build applications or basically little scripts that would simulate an active user to the application itself, and in the end just abuse it as a file storage system. So that is something that was very annoying for the application owner, because there was no way to fix it at that point in time anymore. So in the end, the thing was just broken. So think about what motivations people could have to abuse the application that you're offering. And oftentimes these motivations are different from the ones that you think of, because they're not necessarily specific to your application. So what I would first recommend is just a one-day session of really just brainstorming and thinking how can we mess this thing up in any way that is possible, and then thinking about how can we prevent that. And it's very important to be very creative in this phase and just put everything on the table.
I also have seen another quite nice thing, in my opinion, and it's becoming quite popular, that this works especially if you have at least 2 teams and they are working on the same product, maybe on different feature. And sometimes it's useful to have, when they finish each feature, to have one team trying to break the code of the other team and vice versa. Because when I design my code, I probably have in mind some kind of possible failures that my code can have, but not everything. While the other team that may just know what is the feature, but not how has been implemented, may have other ideas to break your code. So it's quite funny also if in the work environment to break other people's code, but it's effective in preventing most of the problems. Of course, you cannot prevent all the problems you can have, but you can help to increase the quality of your application also in this way.
I think another aspect in terms of security, and you might be security conscious in mind that you might use a service to store your source, some sort of source control that you're not hosting, and you've decided that you're going to have all your passwords in a repository outside from your application, and you decide to check it into source control. And then you might even go, hey, we'll keep that private because we don't want to have anyone else outside of the team get to it. But what happens if that service gets hacked or someone can get access to that repository and you've got plain text passwords sitting there in a repo? It's stuff like that of thinking about, okay, well, what are the services, like what's the services that I'm using that could they also get or have a vulnerability to get access to my secrets that will lead to an attack on that system?
Yeah, we just had one plain text power in my company repository yesterday, and that drive my CTO crazy. He's like screaming on the chat room. So I saw the queue of like 10 minutes left. So I guess like it's time to see if there's any questions from the floor, and well, someone's already like.
One of the worst practices in web development has been that people try to choose the tools that they are comfortable with rather than trying to choose the tools that the product would benefit most with. Please feel free to argue that point. It's a lovely debate class. The question, however, is in your experience, what are the tools or the tips that you could provide to us when you try to choose which kind of language, which framework, which database, which workers, which cloud, or which deployment strategies you use when you're trying to decide what are the right tools for the right product?
So specifically on picking the right tools, we've actually just gone through a process at Mondo where we needed to select a couple of new asynchronous message queues. Now we already use one in production. We use a tool called NSQ. And it's pretty good, but it doesn't necessarily have all of the right properties we wanted. So in order to go through that process, we just evaluated all of the other ones we needed. And that included both running our own on our own infrastructure, which currently runs on Amazon, but also using the outsourced tools that are provided. So as an example, Amazon Kinesis, Google PubSub, and various other kind of message queues. And very simply, we made an extremely long list of requirements, things that we needed, things that would be nice to have. And then we just went through and ticked them off. And I mean, we spent like a day or two on it. And we've used a couple of those tools before. So we know that 3 or 4 of them would definitely suit our purposes already. But having gone through that process means that when we're not sure about it in 6 months' time, we can kind of come back to this and go, this is why we picked that tool. And these are the reasons at that time. And they may not be valid in 6 months, but at the point right now, then they are. So I think that applies for like specific tool. Our web frameworks is again, a very different matter. I think it depends on literally every tool is very, very different.
I guess coming back to the first point you made there about choosing the tool or framework that you're comfortable with outside of what should be used for the application. You could also go the other extent and go, I only want to use the hot right now tools, and your team might have a fairly steep learning curve those tools might be great for the application, but then you've also got to look at what your team's capable of as well. I think most tools out there could probably satisfy most of the jobs that you might want for building your application. But if you have a team of people that, let's for instance use the hot topic, and we haven't even said it yet, of Docker. Hey, your team might not have any experience using Docker, even though it might bring value to it, but should you really use it straight away? Maybe not.
So, any more questions from the floor? Here's a gentleman here.
Hi, just a question. For startup environment, it's all about growth. I mean, most of the time, developer resources are used to implement new features or, making the product great. And most of the times, let's say we don't have the time and resource to do the code review. I mean, or people come and go. I mean, the developers, they go away and the new guys come in. The new guys don't know the security practices and they make mistakes. It's the headache that I don't have the time to do the code review because there are others. I mean, it's all about expanding. So what kind of suggestions in building great and secure software can you give to the startup?
So if your problem is that your developers change frequently because they quit their job and go work for somebody else, and you don't have the time to have a code and security review for your product, the problem is one that most likely cannot be solved technically, but one that can be solved socially. You should probably revise your business model or business strategy if this is a continuous problem that you're facing.
I'll agree with that one, is that you do need to make time for building in quality into your platform, whatever that might be. And when we say quality, that might be code quality, it might be security practices, but it's also then keeping your developers happy, and you get new developers on, doing code reviews with them will expand their knowledge of your platform as well, and hopefully make them produce really good quality software for you as well.
Just quickly as well, I think if you're saying that you don't have time to do code review, what you'll probably then find is you spend that amount of time fixing the problems that would have been picked up in code review later. So although it seems like a good trade-off to like very quickly build code and quickly ship it, then the amount of time that people spend having to fix problems in production or debug why these things are happening is probably more than the amount of time that you'd save by having those things. So I think it's a very positive thing. I personally find code reviews great because it helps me like pick up on better ways to do things or bugs that I would have otherwise not noticed. And sometimes people pick up like a 1-character bug in like 1,000 lines of code, which arguably should be much shorter changes, but it's incredible that people do that. And I think is a positive experience for everyone on the team to kind of go through that review process.
Actually, I do have one thing to add there. I mean, in my experience on managing the team here, like if you do code review, I think you can always start with try to ask everyone commit like really small code change, try to break it down, so that makes the team find it easier. Instead of like spending like hours on code review, maybe they can just spend like 15 minutes or something. So any other questions from the floor? Okay.
Hi. Really enjoying the panel, by the way. It's more like a thought, not a question in particular. So, because we were talking about over-engineering a lot and over-abstraction, my favorite topic, by the way. And I think we are confusing two things, which is over-engineering and bad code. And I was wondering about you guys' opinions about where does that come from? Because, I mean, we all use frameworks, and those frameworks are kind of primitive. And they don't provide, in my opinion, they don't provide enough abstraction layers, enough guidance for developers where to put code. So they start cranking out abstractions and engineer stuff and introduce objects and layers. And that's because, in my opinion, and that ends up in bad code, which you call over-engineering. So my question is, what do you think about, are our frameworks at the moment in Ruby, in Python, in, I don't know, Go, are they providing enough abstractions? Is that maybe the problem, that we don't have enough over-engineering? And is that the reason that people write complicated code?
Well, I can answer on the first part. I mean, you're right. Sometimes over-engineering is confused with bad code, but most of the time, over-engineering and bad code goes together, because this is quite sad, but most of the time, when you try to over-engineer your code, you start to introduce some patterns and some things that are not really good for your application in terms of security, in terms of performances, and in terms of general code quality. So this is why, of course, you can have bad code also without over-engineering it, and I've seen a lot of time. But yeah, most of the time they come together. And I don't know about the second part of his question.
I would first of all certainly agree with what you said. Usually they come together. So generally speaking, probably the frameworks that are being used today are better than having somebody do it all over again by themselves. On the other hand, my personal experience with frameworks is always a bit, I don't trust them. So, for example, when there's like a database, a function to access the database, I'm always, suspicious whether it actually does the job that I want to, and I'm always feeling scared when I put some input into this function because I don't know if it sanitizes it correctly. Most likely, the function is going to do it much better than I could have ever done it. But then I oftentimes get to the point that the function cannot do a thing that I want to do to my database. A certain query is not supported. And then I find myself implementing the query myself again, circumventing the framework's security mechanisms. And at that point in time, there are two possibilities. Either, indeed, I was at the point that I found after writing 100 lines of code, the limitations of the framework, or I didn't search Google or Stack Overflow well enough to find how the framework does what I wanted to do. And that's how, in the end, you find people that are experts in their framework. And then we get to the prior question: do we want people to use a new framework every time, or do we want people to operate and code in the environment that they feel comfortable in? And I would probably opt for the latter, and not for just trying to use frameworks over and over again. I think there's a
keep it short, please.
So sorry, maybe I misput my suggestion. So what I was trying to say is, do we maybe have to use even more frameworks? Like using Rails doesn't mean you're sorted. What I was trying to say is, maybe we should have frameworks in frameworks which give you abstractions so that developers don't have to introduce them, and then the over-engineering is kind of open source supported.
So framework of frameworks. Probably that's the next step, yeah.
And I think realistically, in your company, you'll end up with something like that anyway. So if you start with Rails, for example, you have an application, it started off really, really basic, and that meant you got to market really, really quick. Great. And then realistically, over the next 2 or 3 years, everyone in your company is going to be adding features to that. So I think it's important just to keep track of what things are added and make sure that someone is taking care of and maintaining essentially like a platform within your company. And some companies have platform teams. I personally worked on a platform team in my previous employer, and that meant that we were responsible for taking care of those kind of systems, make it easier for developers to write secure and performant code, and just kind of maintaining that over time.
Great. So I guess we have to wrap up here. I think many of us are hungry already. And then thanks panelists for the great discussion. I guess like people can still continue to chat over at the lunch. So someone take over the stage, please.
Oh, sorry. So sorry. Before the lunch break, there are